Hello students, welcome to today's class. So today we will see question of the solution part 8. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. In this session, we will be practicing questions from 58 to 64. Question says that the vapor pressure of benzene at a certain temperature is 640 mm of Hg. A non-volatile, non-electrolyte solute weighing 2.175 gram is added to 39.0 gram of benzene. The vapor pressure of the solution is 600 mm Hg. What is the molecular weight of the solid substance? Options are A 6.96 U, B 65.2 U, C 63.8 U, and D none of the above. So in this case, the U is signifying unified mass. Your time to solve this question starts now. Time is up. In this question, what is being given? It is given that the vapor pressure of benzene, that is pure benzene, is 640 mm of Hg. Now, if you add a non-volatile, non-electrolyte solute whose weight is 2.175 gram and that thing is added to 39 gram of benzene, then the vapor pressure of the solution becomes 600 mm Hg. You have to now calculate that what is the molecular weight of the solid substance. The correct answer will be B. We know that the relative lowering of vapor pressure is equals to the mole fraction of the solute. So we have written the mole fraction of the solute as number of moles of solute by total number of moles. Further, we have simplified it to weight by the molecular weight. Okay. Here we have written the relative lowering of vapor pressure. So this is the lowering and we are relating it with respect to the original one. If you put the values of the given symbols, then you will get 640 minus 600 by 640. Here we have the weight of the solute as 2.175. M2 is being assumed to be the molar mass of the solute or the molecular weight of the solute. This is again the weight of the solute. Now we know that the benzene mass is 39 and the molecular weight of benzene is also known, 78. You can easily calculate it. C6H6 is the formula. So 12 6 ja plus 6 into 1, you will get it 78. Now if I simplify it further for M2, then on calculating it further, we have cross multiplied it. This gives you your molar weight as 65.2 U. Clear? So this is the molar weight of the solid that has been added. Next question. The vapor pressure of a solvent decreases by 10 mm of Hg or 10 mm of mercury. Now, when it is happening, when we are adding a non-volatile solute to the solvent, in that case, your mole fraction of the solute is given as 0.2. Next case, what we are doing? We are decreasing the vapor pressure again by adding a different amount of solute. Now, in this case, you have to calculate the mole fraction of the solvent. Your options are A 0.8, B 0.6, C 0.4 and D 0.7. In this question, what we have done? We have taken two situations. First situation is saying that the decrease is of 10 mm and in that case your mole fraction of solute is 0.2 and in the second case your vapor pressure decreases 20 mm and in that case you have to calculate the mole fraction of the solvent. Correct answer will be B. So let us assume that your chi1 is the mole fraction of the solvent. Chi2 is the mole fraction of the solute. So we have assumed these two things. If I write the formula, so relative lowering of vapor pressure is equal to the mole fraction of the solute. We know it very well. So we put the values. So the first case, your delta P, that is your change in pressure, is 10 divided by the initial pressure. is equals to the mole fraction of the solute, which is 0.2. That will give you your P naught. Okay, for pure solvent, it is 50 mmHg. Now for the second case, if we calculate the relative lowering, so it will be 20 by 50. Clear? Which is equals to your mole fraction of the solute. If you calculate it further, you will get chi2 as 0.4. But what do we need? We need the mole fraction of the solvent. So since it is a binary solution, just subtract this value from 1 and you will get the value of the mole fraction of the solvent, which is 0.6. Next question. At 310 Kelvin, the vapor pressure of an ideal solution contains 2 moles of A and 3 moles of B. And in that case, your vapor pressure is 550 mm of Hg. Now at the same pressure, if 1 mole of B is added to the solution, the vapor pressure of the solution decreases by 10 mm. What is the vapor pressure? Vapor pressure of the pure state of A. Options are 460 mmHg, B 610 mmHg, C 360 mmHg, and D 750 mmHg. The question is saying that we are taking the temperature 300 Kelvin, and at this temperature, the vapor pressure of the ideal solution containing 2 moles of A and 3 moles of B is having a vapor pressure of 550 mm of Hg. Now, in this situation, what we are doing is we are adding 1 mole of B, clear, to the same solution, and the vapor pressure of the solution increases by 10 mm. Okay, so the vapor pressure increases by 10 mm. So what is the vapor pressure of A in its pure state? It is being asked. Correct answer is A. We know according to Dalton's law that the pressure is equals to the individual contribution from each component. So PA will be the contribution from the A and PB will be the contribution from the B. Now applying the Raoult's law, we have written PA equal to chi A PA naught, where chi A is the mole fraction and PA naught is the say vapor pressure of the pure A. Similarly, we can say it for chi B PB naught. Now putting the values, the total pressure is 550. Chi A is 2 by 5 for the first situation, where 2 moles of A and 3 moles of B are present. And for the second situation, we will calculate it. Now for the B, it will be 3 by 5. This will give you a equation which is 2PA naught plus 3P naught B, which is 2750. And this is equation number 1. Now, what we are doing is we are adding 1 mole of B. So for the second case, it is becoming 560, right? Only the difference is that now instead of taking 5 here, we are taking 6 here. But the number of moles of A is still same, so we keep it as 2. But the number of moles of B is increased by 1, so 4 by 6, P naught B. Here again we got another equation for the same two variables, which is P naught A and P naught B. Clear? So we name this equation as equation number 2. If we solve equation 1 and equation 2, we will get P naught A as 460 mm of Hg. So it's very easy. There are two equations and both of these are in two variables and thus both variables are same. So if you solve both of these equations, you will get P naught A as 460 mm of Hg. Moving on to the next question, which one of the following statements is false? Options are A. Raoult's law states that vapor pressure of a component over a solution is proportional to its mole fraction. Option number B. The osmotic pressure of a solution is given by pi is equals to mRT, where capital M is the molarity of the solution. Option C. The correct order of osmotic pressure of 0.01 molar aqueous solution of each compound is BaCl2 first of all, then BaCl2, then KCl, then the acetic acid, and then your sucrose. Next is 2 sucrose solution of same molality prepared in different solvents will have the same freezing point depression. So you have some time to solve this question. Your time starts now. Your time is up. We have to identify the incorrect or the false statement? So the false statement is D. So we know that for A, if we see that PA equal to chi A P naught. So therefore your option A is correct. If I talk about the option 2, that is option number B, we have pi is equals to IMRT. So this option is also correct because Ventoff factor is 1. Talking about statement C, so pi is directly proportional to I. So we can say that greater the value of I, greater is the value of pi. And hence BaCl2 is strong electrolyte. So therefore I value will be 3 for BaCl2. For KCl it will be again 2. Sorry, for BaCl2 it is 3, not 2, it is 3. For KCl it is 2. For carboxylic acid, it will be less than 2. Why? Because carboxylic acid is not dissociating completely in the water, as it is a weak electrolyte. And for sucrose, it is 1 because it is a non-electrolyte. So one molecule of sucrose will be 1 molecule. It will not dissociate in water. And therefore, arranging in the order of the I, we get barium chloride first, potassium chloride, acetic acid, and then sugar. So therefore, option C is also correct. What about option D? So we know that the depression in freezing point is dependent upon the solvent nature because it is help in determining Kf value. And since you are changing the solvent, so your delta Tf will also change. So the value of depression in freezing point for both solution will be different for this reason, and option D will be incorrect, or the statement D will be incorrect. Next question. 2 beakers of capacity 500 ml were taken. One of these beakers labeled as A was filled with 400 ml water, whereas beaker labeled B was filled with 400 ml of 2 molar solution of NaCl. At the same temperature, both the beakers were placed in a closed container of same material and same capacity as shown in figure here, right? At a given temperature, which of the following statement is correct about the vapor pressure of pure water and that of NaCl solution? Options are A. Vapor pressure of container A is more than that in container B. B. Vapor pressure of container A is less than that in container B. Option number C. Vapor pressure is equal in both the container. And option number D. Vapor pressure in container B is twice the vapor pressure in container A. So your time to solve this question starts now. Your time is up. In this question, we are given that you have a 500 ml beaker and there are 2 of its kind. Now, one of these is labeled as A and that thing is filled with 400 ml of water. And the other B is also filled with 400 ml of water. And in this case, your molarity is 2m of NaCl. Now we are asked that at the same temperature, both beakers were placed in a closed container of same material. And at the given temperature, which of the following statement is correct, right? About the vapor pressure of pure water and that of NaCl solution. So correct answer is A. Therefore, the correct statement is A. So solution says that due to presence of the non-volatile solute NaCl in the beaker, the vapor pressure of beaker B decreases and become less than that of A. So since NaCl is a non-volatile one, upon addition of this to the solvent, decreases what? Decreases the vapor pressure of the resulting solution. Next question. A 0.001 molar solution of PTNH3 whole 4 Cl4 in water had a freezing point depression of 0.005 degrees Celsius. If Kf for water is 1.80, the correct formulation of the above formula is. Options are, so in first case we have PTNH3 whole 4 Cl3, then outside the coordination sphere we have Cl. Then in the second case we have this PTNH3 whole 4 Cl2, outside the coordination sphere we have Cl2. Option number C, PTNH3 whole 4Cl. Outside the coordination sphere we have this Cl3. And option D is PTNH3 whole 4Cl4. So you have 10 seconds to solve this question. Your time starts now. Your time is up. The question is saying that we have a 0.001 molar solution of this given complex in water which has a freezing depression in freezing point as 0.004 degrees Celsius. Given that your water Kf is 1.80, you have to say that which of the given is the correct formulation of the above molecule. So correct answer is B. So suppose for the given complex which is PTNH3 whole 4Cl4, the dissociation occurs. So that will give you how many molecules? So suppose we are taking n moles, then you will get the same number of molecules because the primary valency here is not being satisfied by any of the anion. So the number of moles of complex is equal to the Ventov factor. So I is equals to n. But from the given data, we are saying that delta T is equal to IKFM. We know the formula. If I put this values here, so it will give 0.0054, 1.80 kf and 0.001 as the molality. So n will be equals to 3. So we can clearly say that the formula must not be this. Okay, it would be this one. According to this formula, or the complex will dissociate into 2 chloride ion and 1 complex ion. That is total of 3, and the calculated value is also 3. Clear? Next question. Seawater is found to contain 5.85% of NaCl and 9.5% of MgCl2, that is magnesium chloride, by weight of the solution. Calculate its normal boiling point assuming 80% ionization for NaCl and 50% ionization for magnesium chloride. The Kb for H2O is given as 0.51 Kelvin kg per mole. Your options are A 101.4 degrees Celsius, B 102.29 degrees Celsius, C 103.27 degrees Celsius, and D 99.46 degrees Celsius. So your time to solve this question starts now. Your time is up. The question is saying that we are given the seawater concentration. It is being said that 5.81% NaCl and 9.5% MgCl2, and that percentage is given in terms of weight. Now you have to calculate its normal boiling point, assuming that only 80% of ionization for NaCl is taking place and 50% ionization for magnesium chloride is taking place. Also, the ebullioscopic constant or the molar elevation constant for water is given as 0.51 Kelvin kg per mole. Correct answer will be B. We know that 100 gram of the solution contains 5.85 gram NaCl. How do we know that? Because the percentage is given and that percentage is by weight. So 100 gram of the solution will contain this gram of NaCl, that is 5.85 gram of NaCl. Or we can say that 0.1 mole of NaCl. So divide this thing by 58.5, which is the molar mass of sodium chloride. That will give you 0.1 mole of NaCl. Next thing we know is that 100 gram of solution also contain 9.50 gram of magnesium chloride, which is 0.1 mole of magnesium chloride. Because the molecular weight or the molar mass of magnesium chloride is again 95. So that will equal to 0.1 mole of MgCl2. Hence, we can write that the weight of solvent is equals to 100 minus 5.85 plus 9.50, because these two things are percentage. These two percentage things are given here. So that will give you the weight of water as 84.65 grams. So this is the weight of water. Next thing we know is that NaCl is ionizing up to 80%. So therefore, I is equals to 1 plus y minus 1x and 1 plus x. Now since x, which is the dissociation constant, its value is 0.8, so that will give you I as 1.8. So why we have taken x as 0.8? Because 80% is the percentage ionization, whereas we are seeing the we are considering the fractional ionization. In this case, your y is what? Is the number of total number of solid particles, and x is the degree of ionization. And hence, what is the number of moles of NaCl? Very easy, 1.8 into 0.1. Okay, so in 0.1 mole, we will have this much number, this much mole of this, or this much I value. Clear? Second thing, MgCl2 is ionizing up to 50%. So we can write this equation here. Now again, if you consider the first equation that is being written here, and if you put x is equals to 1 by 2, then we get this whole value of I as 2. So what will be the number of moles of MgCl2? So it will be 2 into 0.1, which is 0.2. So what is the total number of moles? It is 0.18018 and 0.20, which is 0.38. Next thing is that N1 plus N2 multiplied by I is 0.38. So we put the elevation in boiling point, delta Tb is equals to kbm, I value is here, and this is the molecular weight N1 N2 by W2 multiplied by 1000. To convert this thing into what? To convert this thing into kgs. If you put all these values, so you will get it as 2.29 degrees Celsius or 2.29 Kelvin, because it is change in temperature, it can have any unit. What will be the boiling point now of the solution? 100 degrees Celsius is the normal one, 2.29 is the elevation, so that will give you 102.29 degrees Celsius as the new boiling point of the given given solution. So this was all for the today's question session. Thank you.